Hello everyone, my name is Kiran Kamreddy. I am a product manager at MarkLogic. I'm joined by our principal solution engineer Biju George, and we plan to talk about MarkLogic Data Hub Service and how can you get ready for a successful the Data Hub Service implementation. Here is a quick agenda that we will follow for this session today. First, I'll give you a brief overview of the Data Hub services, go over the architecture, contrast the service with MarkLogic server capabilities. Then we'll talk about readiness from different dimensions and angles, like how can you be ready from a networking perspective, scaling perspective, billing perspective, authentication and authorization perspective, and high availability. Then Biju will talk about some cloud native architectures that are a better fit with DHS and how DHS enables them. Then we will end with a checklist of items that lets you better prepare to roll in DHS. First, let's quickly go get an overview of MarkLogic Data Hub Service. So the MarkLogic Data Hub Service is a fast, fully automated cloud service that enables integration of data from silos. The service packages the core MarkLogic server software and the Data Hub software and the cloud native services to enable agile teams to immediately start integrating and curating data for both operational and analytical use cases. DHS is delivered as a cloud service, and like many cloud services, it auto scales, which means capacity is added or removed on an on-demand basis. But unlike many cloud services, Data Hub Service is cost effective and has predictable costs. I want to talk about a few foundational principles around Data Hub Service. Firstly, it's a completely managed service, meaning all the hardware, software, the MarkLogic cluster, the Data Hub Framework cluster, and other cloud native services like Lambda are already deployed, configured, and ready to go. You only need to bring your data and your use case. It's a point and click experience, and MarkLogic runs the operational backend systems end to end. This lets you and our customers focus on the things that matter them the most, which is their data and their use cases. Second, the service scales independently of workload types, meaning your ingestion workload is not affected by the operational workload or your business intelligence workload. You won't have the noisy neighbor problem on the Data Hub service. Scaling is completely automated, meaning there is absolutely no manual intervention happening. And as the workload increases, the infrastructure behind it scales accordingly, and vice versa, meaning the infrastructure shrinks if there is no workload or if the service is being idle. Third, the high availability and redundancy is something that is built across the multiple components that make up the service so that the service overall is highly available and there are copies of backups available in case of data loss or data corruption events. Simplicity of billing is another unique value proposition on the service. There is only one major dimension across which you pay, and that is MarkLogic Consumption Unit, or MCU for short. If you contrast it with the number of services you have to put together to do data integration in AWS and Azure, think about the complex bill that you are going to receive, which has multiple line items with charges for multiple services, making the billing understanding very complex. But here, the billing is very simple, and it is just one line item talking about MarkLogic Consumption Unit, MCU. The service has the service delivers modern UI experiences. You interact and experience the service through modern web-based UIs for both administration activities like creating a network, creating a service, creating a user, or for user activities like defining your ingestion and curation flows via our newly announced Data Hub Central. The entire experience is very modern and uses intuitive web-based user interfaces. Finally, the Data Hub service uniquely positions you to take advantage of the serverless and cloud-native tools and utilities provided by the native cloud vendors like AWS and Azure. These native services have inbuilt reliability, scalability, and security aspects so that you don't have to think about building them from scratch. You simply hook them up with the service to define your end to end data integration pipelines. Let's talk a little bit about the architecture. Data Hub Services is architected in such a way that there is always a separation of workloads and there is no sharing of resources to avoid the noisy neighbor problem. This allows the service to react, respond, and scale independently. Your ingestion workloads is served by a different infrastructure versus your operational or BI workloads so that you can have a peace of mind of running simultaneous workloads at the same time without worrying about one workload affecting the performance of the other. You can provision the Data Hub service in a secure private virtual network and connect to it via peering so that only clients and the data sources in your virtual network can connect and see the Data Hub service and no one else on the internet can. So thus the service is highly secure. You can use a multitude of tools to ingest data into DHS. Some example of tools can be based on any REST API based. They can be based on any Java based applications. You can also use MarkLogic owned tools like DMSDK, MLCP, especially to ingest the data. And you can also use cloud native solutions like Glue and AWS and step functions, as is the case with AWS, to orchestrate the entire data pipelines. As you can see in the diagram, the DHS is provisioned in a redundant fashion across availability zones, data nodes, which are also called as D nodes, and with backups to S3. We'll talk more about HA in the next few slides. Now, let's talk about how can you be best prepared to start using Data Hub services for your data integration projects. BJ will start with networking and connecting to DHS as that is one of the first things you do once you create a service in the cloud services portal.
Thank you, Kiran. As Kiran said before, one Data Hub service instance is a pre-configured, highly available auto-scaling Data Hub platform in your choice of cloud platform and is ready for securely loading, curating, and delivering data. But how the business applications and users will use the Data Hub service? This is where you think about how your data center and your cloud environments connect to the Data Hub service. We understand that being a fully managed service, it is required to provide multiple secure networking options for the customers to choose from. This would help the customers to integrate with their existing systems both on-premise or in cloud. So in the subsequent slides, I'm going to talk about the different options for connecting to Data Hub service. The first option is a public network. In this option, endpoints which can be accessed publicly are exposed from Data Hub service. Although accessible to public, the endpoints are by default encrypted and are authenticated using user ID credentials. Still, we do not recommend this as a good option for transferring your data over cloud. Public networking is a good option for carrying out simple demonstrations, tryouts, proof of concepts, other quick functional evaluation of the service before you onboard your application and data to Data Hub service. The most popular secure networking option is peering, where you peer your AWS Virtual Private Cloud or the Azure VNet to a Data Hub service. In this option, the traffic between the VPC or VNet and the DHS is private and isolated. We can further authenticate the users through Active Directory. A direct access to the Data Hub service from your network, your on-prem network, is possible through an SSH tunnel and a Bastion host. And we have this setup of peering completely automated, and customers can do all this by themselves. But I have seen customers having more complex cloud network architectures. For example, We have customers who would want to directly connect their data center to Data Hub service. Some customers have other managed services which would need to be connected to Data Hub service. Some other customers need something like a hub and spoke architecture where one Data Hub service need to interact with more than one cloud environments. While peering is the recommended option from us, we can work with your network administrators to evaluate your specific network requirements and configure such complex network scenarios as well. And we have in our roadmap the automation of many of these configurations. With that, let me summarize on what should be considered for successfully architecting with DHS. First, you should determine where are the client applications and users, whether they are in on-prem only, whether they are in a combination of on-prem and VPC and VNet, or only in VPC or VNet. Also ensure that the Active Directory based authentication is supported by your security guidelines. Then you determine the number of connections and the type of connections you need from the Data Hub service. This is required because this really helps the network administrators to plan their work accurately. Now, once the network connectivity is established, then DHS is part of your network. So it is important that you ensure there are no overlapping IP address ranges. And finally, a good familiarity with AWS and Azure networking solutions and offerings will be required to get everything right from the first time itself. Setting up DHS instance is really a one-time task. You can have more than one DHS instance behind one network, and the network connections can survive the instance starts and stops. So, a close attention in the beginning to the networking architecture will make the rest of your journey with DHS much smoother. With that, I hand over to Kiran, who would talk about other exciting concepts of auto scaling, high availability, burst, and billing. Thank you.
Thanks, Biju. Let's now talk about how can you maximize the free burst offered by the Data Hub services. One of the guiding principles for the service is to avoid charging customers for the spikes in the workloads unlike other vendors like AWS and give them some predictability on the cost while allowing them to spike occasionally. How do we do this? The model that we follow is similar to a rollover internet or phone plan. We provision a baseline CPU, memory, I/O, storage per MCU level selected. But this infrastructure is not used uniformly at all the times, and it is sometimes it just sits idle as the customer workloads vary throughout the day. So when there is less workload than the baseline infrastructure can handle, we remove the infrastructure, which helps us save some money. But at the same time, we add credits to the customer bucket. When the workload is higher, we add this infrastructure up to the limit of what the credit allows us, thereby making it free for the customer. So at the end of the day, the customer doesn't pay for this extra infrastructure when he needs, and the customer enjoys this additional compute for servicing his demanding workloads. So the best way to utilize the free burst on Data Hub service is to select the MCU plan per the average workload and not the highest workload, which you typically do for other cloud services, and utilize the free burst for the peak workloads. Let me walk through an example here. Let's say you created a service of 50 MCU capacity after figuring out that this is the MCU level that meets your average workload. The green line shows the capacity that you have created the service with. The red line here that you see on the diagram shows the pattern of the actual consumption, and the blue line shows the MCU credits being accumulated at every 5 minutes. Now, let me explain this in further details. If you look at the red line, you can see that the data hub isn't doing much work overnight until 6 a.m., which is when the workload slowly starts to hit the service. Since the workload is less than the baseline for this period, which means the service has overcapacity for this specific time period, in the backend, we remove the infrastructure and hence save costs, but add the credits as you see that the blue line is going higher on the graph for this time period. But as the usage increases in the morning after 9 a.m., the workload needs more capacity than what is provisioned on the service. Generally, in these situations with other cloud services, your workloads are throttled. However, on the Data Hub service, we add additional infrastructure to the service from the backend as needed as we draw the additional capacity from the accumulated balance from the earlier time periods. And the really nice part is that we do not charge the customer for this extra infrastructure that we supply to the service. At the end of the day, we want to ensure the customer is able to handle this specific spike in the workload while keeping the costs of the service predictable and same at the baseline. Sometimes the consumption actually exceeds even the accumulated credits, as you can see in the example here of that happening around 7 p.m. But that's okay. Only after extended periods where usage consistently exceeds the available balance will the service begin to slowly limit the resources. As the usage completely decreases after 9 p.m. or so, the same cycle repeats and we continue to accumulate credits to be ready to handle the next day's peak workloads. Thus, as you have seen, the Data Hub service allows you to have predictable costs while still be able to handle the spikes in your workloads. Now, let's talk about authorization and authentication on the service. Security is very important to us at MarkLogic, and the service is built with multiple security features. One of them is role-based authorization and authentication on the service and also on the portal. The portal application, which lets you create and modify services, has RBAC on it and has three primary roles. The service admin with permissions to create and modify services, the account admin who can see the account and the billing details, and the security admin who performs security related activities like setting up networks, configuring user directories like LDAP and SAML. We do this role separation to ensure that only users who are able to do what they're supposed to do and not everything else. Similarly, on the service itself, there are specific roles which lets you do certain actions like deploying Data Hub services, run and monitor flows, run Data Hub applications, and a variety of other actions. Again, the idea here is to ensure that users are only able to do what they are assigned to do or what they're supposed to do and not have access to everything else. So what does this mean for your actual implementation? What this means is that you will need to understand what kind of RBAC model does your application or your data integration use case would need, meaning what kind of roles and privileges you need for different tasks, and you have the job of assessing these missing roles and privileges from the ones that come out of the box. So once you assess these gaps in terms of the additional roles that you would need or the additional privileges that you would need, you need to create them on the Data Hub service. And for that, you will need a person or a user having Data Hub security admin role, because only that user can create additional roles and privileges. You'll also need to think about where your directory services are located and what networking options do you need to choose so that the DHS is able to see these directory services and user role mapping. We are also currently working on SAML and single sign-on connectivity so that our customers have more options to choose from in terms of how do they want to connect and talk to DHS. As I mentioned a couple of times earlier, Data Hub Services has high availability and durability built in across and within its architecture. There is a separation of compute and storage nodes so that the failure at one of these levels does not affect the other. The cluster itself is deployed in multiple availability zones so that you're protected against failures at the zone level. The replicas on the database ensure durability in case the node gets lost or, uh, or gets corrupt for any reason. The load balancer, which is the critical point for service being available, is also deployed across availability zones so that they are just highly available. In addition, there are daily and weekly backups automatically configured on the service so that you're protected against any data loss or data corruption events. We also enable disaster recovery across regions manually today, and we're working towards making it available through automation. One of the unique value prop on the service is simplicity in billing. You simply pay for the service according to the MCU level capacity you choose. For example, if you create a 32 MCU service, you pay $4 per hour for the time the service is up and running, and that's it. You can also buy contracts, which will give you about 40% discounts. Buying a contract doesn't restrict you from using more MCUs. You can still do that, but you'll be charged at the regular price and not the discounted price that the MCU contracts would give you. We've also introduced a new tier of service called low priority service, which lowers the cost by even more another 40%. The low priority service does not have auto scaling or high availability features owing to the low cost nature of it, and it is suitable for dev and test workloads at a very, very low cost or usage where you don't need to auto scale like predictable batch loading workloads. There is a billing for storage consumed across MarkLogic databases, backups, and logs, and there is also billing for network traffic through the endpoints, but these are just passed through from the cloud vendor to the customer directly. The billing itself is experienced through a modern web UI which shows consolidated bills across all the services and across all the components so, so that they can be charged back to different business units internally. We also have integration with native cloud providers so that the customer has an option to just get one bill for all of their cloud usage versus bills from both MarkLogic and AWS. This way, customers can take advantage of any long term contracts or discounts that they already have with the native cloud vendors like AWS and Azure. Here's a quick snapshot of the detailed billing that the customers can see on their portal. On the left-hand side, you see a quick summary of the usage across compute, storage, and network. And on the right-hand side, gives you billing across each component and across each service down to the level of each hour. On the left-hand side, as you can see, how compute costs are separated into discounted MCU contracts price. For example, in this case, it's 17,312, and on-demand MCUs consumed, which is 12,784, as these two MCUs will be billed differently because one is a discounted MCU contract MCU and another is a on-demand regular MCU. On the right hand side, you can see the hourly breakdown and also the breakdown on storage detailing the active storage, which is the MarkLogic database, and also archive storage, which is logs and backups. Now, let's talk about how Data Hub services enable cloud native architectures. Biju will talk about how can you leverage cloud native services and tools and be successful with Data Hub service.
Thank you, Kiran. Once you have figured out the network connectivity and completed building a strong security posture in the cloud, the next thing is building your business use cases with the DHS. Putting it in another perspective, the key problem the Data Hub solves is the data integration problem. It involves getting the data from different sources in your enterprise, harmonizing them, mastering, enriching, and delivering it into different formats. This will require to integrate the Data Hub service into your enterprise data fabric. That is when you think about how to adopt and operationalize the cloud native tools like AWS Lambda or Azure Functions, AWS SQS or Azure Service Bus, AWS SNS or Azure Event Grid, AWS Glue or Azure Data Factory. These are some examples from the rich set of services that cloud providers already have. The attraction of these services is that they are very reliable, they are very stable, they are very easy to implement, and they are already having an enterprise grade. From a developer or an architect who builds data solutions with MarkLogic, what is all required is a different way of thinking on how to take advantage of the cloud tools that exist. Here, we will look at a couple of examples of thinking differently about some of the aspects of Data Hub framework in the cloud. Event-based architecture, a very popular architecture where systems react in real time to a change in another system or data. How do you do it in the on-prem? You would use MarkLogic's built-in APIs for making HTTP or SMTP calls for external services or for generating alerts. From a security layered architecture standpoint and separation of concerns, etc., they were determined as not the correct option in the cloud, and these APIs are no more available in the cloud. Instead, cloud providers have nicely engineered tools to allow messages to flow around. Using those tools help in taking advantage of scalability, the familiarity that the people already know how to do this, and they are already built with enterprise grade security and high observability. I do not want to say that there is one and only one way to do event based architecture in cloud. It is about how you think differently to use the existing tools with DHS. For example, in AWS, an AWS Lambda function wakes up every once in a while to run a query against DHS and stick that into another Amazon service called EventBridge. The EventBridge can have a logic to invoke a simple notification service for sending emails, or it can invoke an AWS step function to run business logic against analyzing the data, or probably generate a report and store it in S3. Another scenario is the operational REST API. With a bunch of code, MarkLogic can do a lot of API management. But in the cloud, we should really push that logic to the API management tools that already exist, like Amazon API Gateway or Azure API Management Service. They are designed to set up your REST API, monitor it, provides authentication, etc. The API management tool can do a bit of transformation and enrichment using step functions or lambdas, and finally call the data service from DHS. So instead of API management in MarkLogic with a lot of custom code, tap into the rich set of cloud native services that already exist. The Data Hub service in cloud can provide a good data orchestration experience if you leverage the right cloud native tools. You can have the advantage of separation of concerns where the data logic is separated from the orchestration logic. These tools are all built to scale. They have very high security and very good monitoring capabilities. MarkLogic is also investing heavily on the orchestration side. Very soon you will see solution templates, reference architectures, etc. to give a great cloud native experience with Data Hub service. With that, I hand it over to Kiran, and thank you again for your time.
Thanks, Biju, for talking about the cloud native tools. Okay, let's summarize the key takeaways from this presentation. To be successful with DHS, firstly, you need to identify your data integration use case and map the use case to the capabilities on Data Hub Service, which means you have to think about the kind of data services that you would need, your ingestion and curation workflows, think about where your data sources are and what kind of tools you would need to ingest the data from those data sources. Remember, Data Hub Service is not the same as working with MarkLogic Server. So you need to think about cloud native services versus doing it inside MarkLogic, um, as Biju explained in some of the earlier slides. Then think about the connectivity options. Would you need public networks or would you need a peer network to connect to DHS? Or would you need like another option like a VPN gateway or a transit gateway? Also, not only about the data sources, think about the connectivity for your directory services so that the service can understand and read the user and role mapping, and then figure out the overall network topology that would work for your project. Be sure to take advantage of the free MCU bursts offered on the service by selecting the right MCU level for the average workload and utilizing the free burst for the peak workloads. And last but not the least, think about the different kinds of cloud native services and tools you will need, and think about how would they interact with DHS to complete your data integration pipeline. As you may have heard during the main product announcement, I am excited to share the newest capability of Data Hub Service, the Data Hub Central. Hub Central provides a collaborative, self-service experience for continuous data integration to create, explore, and share consistent and fit for purpose data assets. It's designed for your data experts to work directly with your data so that they can build your data hub on data hub service without writing any code. If you do not know already, MarkLogic offers free Data Hub Service demo webinars and hands-on trainings, which are completely free to you. Please visit our training website for additional registration details. There are also some interesting episodes around DHS performance and around the overall data integration involving DHS that I would strongly recommend you to attend and listen to. Be sure to check them out. Finally, Biju and I would like to thank you for your time in listening and watching through this episode. If you have any questions, please feel free to contact either Biju or myself at the email addresses displayed on your screen. Thank you.